Hello and welcome everyone. You need a router agent in your agentic workflows. Today, I will demonstrate a very common problem that we all face while writing a tool calling agent and the solution to that too. So imagine a situation where you are asking a very simple question to your Olama server, right? So to your large language model hosted locally. And you're asking it, hey, tell me a joke. And it will come up with a direct response and it will probably tell you why did the chicken cross the road or some lame joke over here. And which is okay, which is all right. It's a text generation model. And whatever intelligent large language model you have in the backend, it's giving you a response back, which is expected. But let's say you want a tool call response back. So Olama supports the tool calling feature where you can provide certain tools to the large language model. And how you do that? So whenever you are sending a request to the large language model, you send the available tools also along with the request to your LLM, to your Olama server. And I'll demonstrate all that in the code in a bit, but I want to talk about concepts over here first. So you will send that this large language model has get weather and get time tools available, let's say. And the large language model, if you ask it a question, what is the system time? Then it will evaluate which tools it can execute to get the system time, right? So the large language model will, as a response, instead of sending and making up a response, will actually send you a response back that, hey, if you execute the get time tool, right? So if you execute the get time tool, you probably will get the response back. So it sends you the name of the function, and it also sends you the attributes or the arguments that you need to run to execute this function. And then your code base will call this function and you will execute it, which is okay. So this concept in theory is fine, right? You made certain tools available to LLM and LLM performed a tool call or gave you an indication that you need to perform this particular tool call. Now, this is where the problem arises. The problem that we all run into is, and I'll demo this problem over here too, but hear me out first over here, that you will make certain tools available to a large language model. For example, you'll say, hey, you have get weather tool available, you have get time tool available. And then you will ask a question that is unrelated to the tools that are available to the large language model. For example, you'll ask, hey, tell me a joke. And you will get one of the tool calls back as a response back, right? And this is very frustrating. So even though we have these intelligent large language models, Llama 3.3, that is supposed to be performing as good as 4 or 5 billion parameter model, but the quantized version of many of these models are actually incapable sometimes in performing the no tool call scenario, right? If I'm asking you to tell me a joke, you do not have to respond back with the get time tool call. So somehow these large language models get stuck in a scenario or in a situation where when they see that a tool is available, they always want to structure the response back in terms of a tool call. Even though a tool call is not necessary, they will still try to respond back with a tool call. And yes, you can enhance your system prompt. And I've done a lot of prompt engineering to try to get rid of such a situation. However, it is almost impossible to not run into a situation where you make certain tools available to a large language model, and large language model always would like to structure your response back in the tool call response. So let me show you a few things that I'm talking about over here. And I will also show you what's the solution to this. So the solution at a very high level is that we use a routing logic in between. And the routing logic determines whether the tool call needs to be done or a no tool call needs to be done. And that is what I'm going to show you today, the router agent or the routing logic, which intercepts the request even before that and uses the large language model to perform an intelligent routing and then perform a tool call response only if it is necessary. And this is a foolproof method. It is 100% guaranteed method that I've developed over here, and it's a known concept, but I've written some code over here to prove this, and this will really enhance all your AI agents and agentic workflows that you have. Okay, so enough being said, let's see what all we'll need to implement such kind of routing logic. So Olama recently came out with a structured response. So I'll talk about some of the programmatic details over here about structured response, and I will also talk about the situation where we will use the structured response. So let me first demo to you what is actually the issue that we are facing over here, right? So you'll see in 03 Olama function calling basic example over here, what we have done is we have made two tools, which is get current weather and get system time. Two tools, we are making it available to a large language model over here. So if you'll see, these are the two tools that we are making available to our Quen 2.5 coder model. And I think there is some extra code over here that I'll get rid of. We do not need that. So I'm going to delete that over here. So what I'm doing is I have my Olama server in the basement hosted at aimtcl.lan. You can have local host over here. And I have these two tools that I'm making available to my large language model. And you will see I'll associate that. And this is the system prompt over here that you are a knowledgeable and helpful AI assistant. And you will see that I'm very specifically asking in the system message that, hey, if there are some generic questions, then just answer back with a simple, response, right? So what I'm asking it is that, hey, if it is a generic question, like tell me a joke, do not give a tool response, but just directly answer back. But it does not do that. And this is what I'm going to demo to you. So I have associated tools and I have requested to respond back now. So let's just run this, and you will see that there are these many different queries that I will throw at the model to evaluate whether the model is able to perform no tools in the events where it should not be performing tool calls, right? So only two tools are available to the model, the weather tool and the time tool. Anything else, it should not be performing a tool call. So let's see. So what I'll do is Python 03 Olama function calling basic, right? So I'm going to run this, and it's the very first question is, hey, tell me a joke about programming, right? Decent. Why do programmers always mix up Halloween and Christmas? Because October 31st equals December 25. Okay, whatever it is, right? But it worked good over here. Fine. Let's go to the next one. So the next question is, what is the current temperature and forecast for tomorrow? So let's see that. And it did a tool call. It did a tool call accurately. We get current weather and location of Woodbury, Minnesota. That's fine. That's a good positive scenario over here. Let's move on to the third question now. So remember, we only have two tools available, get current weather and get system time, right? So these are the only two tools it should call. Let's see. Let's go to the next one. So turn on the living room lights, and this is where things start getting funny. So you see that it is saying, hey, I'm attempting to do the control lights tool call, right? This tool doesn't exist. There is no way it can perform this tool call. This tool does not even exist. And I haven't even made it available to it in the request. So the only two tools that exist are these two tools, which have been passed on to the request, but it is attempting to do a tool call. It has made up this tool call name, and it is obviously going to fail. So let's go to the next question that we have over here. So the next question is, what is the exact time in New York City right now, right? So let's go to that. And okay, fine. It did a get system time and location of New York. So which is good. It did the correct tool call over here for this. And let's go to the next one. Solve the math problem. What is 2 plus 2 multiplied by 3? And see this again. Again, it did this. So it is attempting to do a tool call to solve a math problem, right? There is no tool called solve math problem. So it is failing at it. And let's go to the next question. What are the weather conditions in San Francisco? Good job. It invoked a tool called get weather, current weather. So it does work for the correct tools. The problem happens when that particular tool is not available. It attempts to make up a tool call which it should not, right? So for example, can you turn off all the lights in the house? Let's go to that question now. Let's see, control home devices. There is no tool called that. Right, so I'm going to just quickly run through the next set of questions. Square root of 144, and it tried to get a system time for square root of 144. God knows why. So let's keep on going. Conditions in Paris. So that is good. It found out the correct get current weather. Let's go to the next one. Relaxing music. It's trying to do a play music. That doesn't exist. Let's go to the next one. Capital of France. And it's trying to get a system time to get the capital of France. And of course, it got the result of 3 p.m. over there. How long does it take to fly from New York to Tokyo? It's trying to get a system time because it just thought it is a time related question. So it is just doing that. And then set an alarm for 6:30 a.m. Again, set alarm method doesn't exist. Okay, an interesting fact about space. And okay, so in this time, it actually did do a good generic response back, which is what we wanted. And let's go to the last one, get the system time on this device. And it did the get system time and this. So you'll see that it failed in so many instances, right? So, and the instances in which it failed is where it was making up the tool calls for the tools that do not exist. Or it is attempting to go to certain existing tools when those tools shouldn't be reached out to, right? For example, capital of France. You cannot get an answer to the capital of France by executing the get system time tool, right? It's impossible to do that. So this is exactly the situation that I'm talking about, that if you make certain tools available to the large language model, and if you ask a question that is not relevant to these tools, the large language model attempts to answer the question by executing the tools. And this is not good. This is not something what we want over here. So how do we resolve this situation? So the way to resolve the situation is to have something called a router agent in between. So what is a router agent? Let me show you the diagram for that. So right here, that you can see how the routing agent is being used over here. So how we do this is we'll ask a question to the large language model, right? So the user will ask the same question to the large language model. And instead of this question directly being sent to the LLM, like how it is being sent over here with tool in the request and all that, it's actually sent to a router agent. And router agent actually is the same LLM interaction, right? So what it'll do is you'll reach out to the Olama server using this router agent, but the router agent's task is to route the requests to either a basic agent or a specialized agent. So if let's say you have asked a question, tell me a joke, right? So in that case, it will directly, let me just make it bigger. So if you have asked a question, tell me a joke, then the router agent will route this request to the basic, as a basic request to the basic agent. And the basic agent calls do not have any tools associated to them. So when you do not have any tool associated to it, and you ask this question to the Olama server, you get a direct response back because there is no tool call associated in the request itself. But let's say if you had your question as, hey, tell me the weather, right? Or so let me just put that over here. So if the request is, what is the weather in Woodbury? In that case, so let me make it red. So we have this demarcation over here. So if you have asked specifically a question that what is the weather in a particular city state, then the router agent will say, this looks like this is a tool call. And router agent has access to the different tools that are potentially available. So instead of it performing a tool call, it actually sends the request to a specialized agent, which has access to only one particular tool this which this particular call needs. So even though the router agent does know about multiple different tools, it just routes the request to the specialized agent. Also in the request, it tells the agent that, hey, these are the tools that you will have access to, and in that list of tools, you give it access to only one single tool, which is the get weather tool. And if it is a time related request, right? So what is the system time? Then you pass the question to the specialized agent with only one single tool as get time. And this makes the task of the large language model really, really easy. So you split it into two different steps. So instead of doing a single call to the Olama server, you do two different calls to Olama server. One call would be to first route the request to the correct agent. And I'll show you in the code how this is working too. But this is where the structured response that the Olama feature has been dropped recently on December 6th comes into picture, where using a structured response, you first classify the request, whether the request requires a tool call or it does not require a tool call. And whenever we are doing these structured responses, we have an option to use enums over here. And this is where enum will also come into picture, that how awesome it is, where you can very clearly define that these are the only tools that are available. So only route the request to a specialized agent if you have one of those available tools in the list of the specialized agent's tools. So let's say if you ask a question about what is 2 plus 2, because the router agent already knows that 2 plus 2 request cannot be answered by get weather or get time tools, it will never route the request to the specialized agent. It will always route such request to the basic agent. And let's say if you have asked, hey, turn off my lights in the office area, the router agent knows that, okay, there is no home automation task or tool available, so I cannot route this to the specialized agent. Whereas we notice that when we ask such question to a large language model with a bunch of tools already available, it makes an attempt to make up a tool call, even though the tool does not exist, right? So let's not see this in action, that how does router agent come into picture and how can we route the requests to the correct agent, basic agent or specialized agent, and how we can do this using simple structured responses in Olama. And I'm not going to be using LangGraph or any framework over here. It's very simple, straightforward implementation. And in future, I will actually modify this, enhance this to make it as a LangGraph based implementation. But first, I just wanted to show you in simple terms how you will implement a routing logic. Okay, so let's go back to our code over here. And this is a simple routing agent example. So over here, all we are doing is, number one, we are setting up two different kinds of agents. So there is a basic agent and a specialized agent. And this is where you will see the enums that we are using. So there is a enum that I'm defining, right? So this enum is coming from directly from Python over here. And we are defining that there is a class agent type, which is of type enum. And what we are saying is that there are two different basic and specialized agents that are available to us. Now, this is important because when we'll define our Pydantic schema down below, then we want to make sure that as part of the Pydantic schema, there are only two options available, basic and specialized. So let's go down and you will see that this is the Pydantic class that we are creating. The custom Pydantic object that we want to have instances of will be of agent type and task type, right? So there are these two tasks that I'm making available to the agent. So I'm just making it home automation and weather right now. I know that we talked about system time and weather, but let's assume there are two different tasks that are available. One is home automation, and then second is weather. So there are only two tasks, and generic is a task for the basic agent. Like if you're asking a simple question, hey, what's the tell me a joke, then it falls into the generic category. So there are two different enums. First enum is for agent type, and the second enum is for task type. So if we go back to our diagram over here, first enum is for agent type, either a basic agent or a specialized agent. And the second enum is for various different tasks that are in the system, which is get weather, get system time, or home automation, right? So these are the different tasks that we have in the system over here. And I have configured only two tasks right now. So once you have these two enums set up, then you make a router decision pydantic object over here, a class over here. So over here, you are defining two different inputs, right? So one is an agent type and second is a task type, right? And this is what we want to get over here. An agent type over here, either basic or specialized agent, and the task type, how many tasks we have. All right. So now that has been done, this is where we define our router logic or routing logic. So let me go down and let me show you over here. So this is the main system prompt for the routing agent. So this is this router agent's system prompt over here. Let's take a look over there. So in this system prompt, what we are saying is that you are a routing decision engine, and your task is to decide the type of agent and task for a given user query. And following are the rules. If a query can be answered without tools and pertains to general information, classify it as agent type basic and task type generic, right? So these are some examples that I have given to it, that if the query pertains to certain domains such as weather or home automation, classify it as specialized and task type as whatever the domain specific task it is, right? So it is either weather or home automation. It will just specify it like that. And a specialized agent cannot handle generic queries, and a basic agent cannot handle domain specific queries, right? So what does that mean? That if you are a basic agent, you cannot have a task type of get weather, right? So if we go over here, a basic agent cannot have a get weather task, and a specialized agent cannot have a generic task. A specialized agent will always have a tool associated with it, and a basic agent will always have a generic task associated with it, no tool associated with it. So let's take a look. These are some examples. If we ask what is the weather outside, it will say agent type is specialized and task type is weather. If we ask turn on the lights in the living room, agent type is specialized, task type is home automation. So we always should provide some examples to the large language model, because this way it has some few short examples to work with. Right, so these are some examples that have been given, and then there is a query that is being provided to it. And it will respond back with the following JSON format. So this really helps the large language model to respond back in a particular way. Right now, when we are asking, so this is the response client.chat. So this is where what we are saying is that, hey, respond back with a structured output. And this is the new feature in Olama where you can use structured outputs now. So if you want to watch, I've made a video right before this video where you can very clearly see how to format your requests and responses to get the structured output back. All right, so I'll link that particular video in the description over here, but let's continue. So what we are saying is that send the request to the large language model and format it in the router decision format, right? And what is the router decision? Router decision is our pydantic object where we are getting the agent type and the task type. So we are getting either this routing decision is for a simple basic agent or it is a specialized agent, right? So this is what it is doing over here. Let me scroll down. And once the large language model gives us this decision, we are just in a way printing it out so we can see that, right? So let's do that. Let's see. So we are going to, this is the 04 example over here for us. So let's run this. I'm going to make this actually a little bigger over here. So Python 04, and you'll see what is the weather outside. And it says that, hey, you should utilize a specialized agent and the task type of weather over here. This is awesome. right? So now it has very clearly categorized it as a specialized agent's task with the task type of weather. And why weather? Because weather tool was made available to it, and that's why weather it is saying. Okay, turn on the living room light. So this falls into the category of home automation. So let's see, and because home automation tool is available to it, I hope it should assign that. So let's see. So specialized and home automation, which is awesome, right? Turn on the living room lights is a home automation task. Okay, tell me a joke. So this is a generic task. So it should not go to specialized agent and the task type should be generic. Let's see. So going again, wow, perfect. So it says, tell me a joke. So it has routed it to basic agent and to the task type of generic, which is awesome. So for tell me a joke, it is routing it to the basic agent, and for more tool calls, it is routing it to specialized agent. This is awesome. So we are not actually sending. So in this example, I'm just stopping right here, right? I'm just stopping right here. I'm not making the call forward, and I will show you the forward call all the way to Olama server in the next example. But at least I wanted to show you the router agent logic over here. All right, let's go to the next question. This is a simple question, right? So let's see. This is a simple question. Of course, it's going to do basic and generic over here. So that is good. Let's go to the next one. How many days are in a year? And it will, of course, do a basic and generic because it is not a tool call. Dim the bedroom lights. This is a home automation related question. So, and it has home automation tools. So it should, yep, routed to specialized with home automation. That's nice. Will it snow tomorrow? This is a weather related question. So I hope it will route it to weather agent. Perfect. Specialized in the task type of weather. Temperature in New York. Again, it's a specialized and task type of weather, which is awesome. Let's do square root of 16. Now this is interesting because when we do not have a router logic, then square root of 16 gets routed to a made up math function that does not exist. Let's see what happens over here. In this scenario, because it is bound by the pydantic schema, right? It cannot answer anything else. The pydantic schema forces it to answer only either basic generic or specialized in the task type of whatever it is. So given that it is bound by very strict criteria, it understands that and only routes it to basic and generic. So this is awesome. So we have overcome a situation where this model, the router agent, is not sending the requests, and it's making more educated decision now versus just randomly creating and making up tool names and function names over here. Okay, let's go to the next one. Play some music in the living room. Looks like a home automation task to me. So it should hopefully do that. Yep, specialized home automation. And tell me something interesting. And let's go back over there. And it does basic and generic. This is really awesome. So our router agent is actually working perfectly, 100% over here, right? So let's go down over here. So what have we achieved? We have achieved this router agent routing logic over here, where we are able to route the request to either basic agent or specialized agent instead of, having just one single agent over here that has a ton of tools available, and which is this example, one single agent having a ton of tools available and then failing to answer the response. So let's build this and let's finish this whole use case end to end, which is after we have identified which agent we need to go to, let's take these calls forward all the way to Olama server. And in the agent scenario, specialized agent scenario, we will give the agent access to the tool and the tool call will be done. And in the basic agent scenario, we will give no tool access and no tool call will be done to the Olama server, which is, so now we are going to number 5, example number 5 over here. Okay, so let's take a look at the code first and then we will come down over here. So the code looks very similar to what we've been seeing before. So we just get these enums, pydantic base model, term color to make the terminal look pretty, Olama's client, and these two tools that we have available to us. And if you want to see more details on these tools and how these tool decorator and tools.py has been set up, then please watch the previous video for which I'll the structured output video for which I'll put a link in the description section. All right. So Now, taking the call all the way to end to end, we'll first set up again our configuration API URL, which is our Olama servers endpoint. The tools, these are the two tools that I'm making available. Please note that we do not have the home automation tool this time. We have a weather tool and get system time tool. So there are two tools that are available to the and to the model over here. All right. So we have these two tools now, and why do we have tool functions and all that? Again, I've talked about this in detail in the previous video, and I'll let you watch that. So now this is where we write some more meaningful code to execute. So we have agent type and task type similar to how we discussed in the router agent example before. A router decision again similar to what we discussed in the router agent example before. The thing that starts changing is two new classes, introduction of two new classes, basic agent and specialized agent, right? So after the decision has been made, after the router decision has been made, then we need to go to either the basic agent or specialized agent and actually execute the logic that is in there. And you'll see there is quite a bit of logic that is in there. So let's take a look and review. So basic agent should not have any tool access, and specialized agent should have tool access, right? So this is what we'll take a look at. So in the basic agent, you'll see that it is a very simple basic agent. Answer the query directly. That's it. There's nothing special going on over here in the system prompt. And in the user prompt, what we are doing is just passing in the query, and then we are getting the answer back. And you'll see that over here in this particular message structure and model, there is no in the payload essentially, right? The payload to Olama, there is no tools that has been made available to it. This is the spot where we add tools. But in this use case for basic agent, there is no tool that is available. And this is a very simple basic agent concept over here. So when a query gets routed to basic agent, there is no tool, and hence the response back will be a very simple response for us. So let me close this now. Let's open a specialized agent. So this specialized agent is where the thing starts looking interesting. So in the specialized agent, you will see that there is a task also being passed in the specialized agent's handle query method, right? So there was a handle query for the basic agent too. There is just one method that we have defined in the agent. So handle query. And in the handle query for the specialized agent, we are passing in the task, and the task type is the same task type that we have created the enum before, right? So there can be only three task types over here, whether get system time or generic. Only three task types can exist. So from this, we will be passing in only one particular task over here, right? So the tool will be only one tool that will be passed in over here. And we will associate that particular tool in the tools array with just one single tool. So the specialized agent will have two things coming out of it, right? So let's see. The specialized agent had the agent type and the task type, these two things that were coming out of it. So once we reach the specialized agent, we already know that we need to execute a particular task, and that task type will be in form of a tool that will be associated when we are sending the request to the large language model. And this is huge, because now what we are saying is that you have access to this particular task type tool, right? So we are modifying the system prompt over here that this particular model has this tool available and use it judiciously. So the request is already formatted in such a way that it is meant for this large language model. And we are also making it aware that you have this tool available to you. So it executes this tool for this purpose. And this is huge, because now you are able to execute a tool by sending only one tool to the large language model, and the most relevant question, the query to the large language model too. So the possibility of it not failing, right? So possibility of it being successful is huge over here now. And then once the tool call response is received, then we go ahead and we perform that exact same tool call, because there is just one tool call in there. I mean, even though we are iterating over here, but there is just one tool call. We'll go ahead and we'll execute that tool call. And if you want to see the details of how we are doing the tool call, I've explained that again in the previous video, and I'll link that in the description section over here. All right. So this is how it is working. And then let me minimize the specialized agent, and then I can show you the router class over here. So router class is the same router class that we saw in the router agent example, where we are just defining that there are multiple tools that are available. And then the router agent or the router activity for Olama is to only pick up the correct agent type and the correct task type for us. All right. So all that is being done. We have basic agent, specialized agent, and router. And this is where we will run the demo to see for all these different prompts, how is our system behaving now. So you notice that previously when we asked questions like what is the square root of 144 and stuff, the tool was failing, which was when we made all the tools available to large language model. Let's see how it works now. So let me make this bigger. Okay, and Python 05 router. Okay, perfect. So you'll see the very first tell me a joke. It goes to router decision is basic and generic, and the basic agent is now reached, and it is the joke that it tells. All right, let's go to the next question, which is current temperature and forecast for tomorrow in Woodbury. So let's go over there. So the router agent routing decision is a specialized agent and weather, right? This is awesome. So now it goes to a specialized agent to handle the query, and task type is weather. And the specialized agent says that, hey, for this particular query, what is the current temperature and forecast for tomorrow in Woodbury? For this query, you need to call the get current weather method, which is awesome. So this has access to only one tool, which is the weather tool, and it does the tool call perfectly over here, and then it gets the answer back from the agent's reply. Okay, that's perfect. Let's go to the next one. Turn on the living room lights. So now note that there is no home automation agent over here, right? There are only no home automation tool. There are only two tools available, which is system time and weather. So it should not be making up the home automation tool and trying to invoke that. Let's see. So yep, perfect. So it says the basic and the generic agent will be invoked over here. So turn on the living room lights and adjust them to 50% brightness. It is just, faking it. It is hallucinating and faking it, but that is good. It invoked the basic and generic agent over here because there is no tool for the specialized agent to actually execute this thing. So let's go to the next one. What is the exact time in New York? And we do have a system time tool available to the large language model. So the router decision should be specialized, awesome, get system time, awesome. And then this actually went to the system time task type with the tool call of get system time. This is really awesome. And the arguments were formatted perfectly by our large language model over here. So this is really awesome. So none of these responses have failed up until now. This was an interesting question. Remember, what is 2 plus 2 multiplied by 3? And last time around it was making up a tool name, and let's see what it does now. So this is good. Router decision is basic and generic, and it actually tried to solve this question instead of making up a tool name and attempting to execute that. This is really awesome. Let's go to the next one. Weather conditions, it should execute the weather tool. Let's see, the routing decision is specialized and weather, and the tool call is get current weather. This is awesome. Let's go to the next question. Turn off all the lights in the house. There is no home automation tool in this case, and it will not go over there. So basic and generic. And then, yep, as a basic agent, I don't have capability. So this time around, it realized that, which is good. At least it is just answering back instead of trying to fake a tool. Okay, square root of 144, it should not fake a math tool. So it should go to generic agent, which it did. And wow, smart math logic over here. Okay, give me a detailed weather report for Paris, France. So it should go to the weather agent. Let's see, the router decision is specialized and weather, and it went to the get weather agent. tool call for the specialized agent, correctly formatted the arguments, and we are here. Okay, play some relaxing music in the bedroom. And there is no home automation agent, so basic and generic, that's fine. And it says that it cannot play music, which is fine too. Capital city of France, this should also go to the generic agent or the basic agent with task type of generic, which is awesome. It did that. Let's go to how long would it take to fly from New York to Tokyo. So see, this is how long. So sometimes models do misinterpret it as system time, but let's see. In this case, it should go to basic and generic because of the router agent in picture over here. So let's see that. So basic and generic, again, this is really awesome. And let's go to the next one. Set an alarm for 6:30 a.m. If there was no router agent, it would have failed, but I trust in the router agent now. Basic and generic. Yep, perfect. So this again is the right choice. Tell me an interesting fact about space. So let's see that. This should go to basic and generic too. Basic and generic. And we do get a perfect answer over here. This is awesome. All right, what's the current system time on this device? This should go to the specialized agent with the get system time attribute. So let's see that. And it goes to the specialized agent with the get system time attribute. This is perfect. This is perfect over here. All right, so this concludes this this router agent, example that I want to show you. But this is how we should be designing. If you have a tool call, just do not associate the tool call directly to an agent and ask it questions that are not related to the tool call. Instead, just break it down into two steps. Step one is a routing step where you do the tool call only when it is necessary by routing it through the specialized agent and only make the correct tool available to that agent, right? So if it is a weather related question, step number one, route it to the specialized agent and only give the weather tool access to the specialized agent. If you change your current implementation, break it down in this way, 100% you will succeed in each and every request, given that your model is decent and good enough. So I'm using Qwen 2.5 Coder 32 billion parameter model, quantized as Q4, and it works awesome. I have never seen a failure whenever I break down my request into router agent with a specialized agent with the single tool made available to it kind of scenario. So feel free to explore the repo, use this 05 example over here, and you will never fail in any agentic implementation that you have. Well, if you guys are watching it up until now, I really thank you for watching this video. And I request you to like, subscribe, and share this video with others if you found it useful. Thank you guys again, and I'll see you in the next one.